Hello class, welcome to Pre-Algebra Lesson 3-2, which is all about rational numbers. By the end of this lesson, you should be able to write rational numbers as fractions and identify and classify rational numbers. So looking at some vocab, two new phrases for you. So first of all, a rational number. A rational number is any number that can be written as a fraction. An irrational number is any number that cannot be written as a fraction. Okay, so make sure you make note of that. That's something that you're going to want to make sure that you memorize. All right, now let's take a look at this diagram. This diagram probably looks a little goofy to you, but we're going to talk about how different numbers are related to each other. So we're going to start by looking at the very innermost circle, okay? This innermost circle here is reserved for whole numbers. Okay, so whole numbers are numbers that aren't decimals, aren't anything like that. So like 1, 2, 3, 4, 5, and actually 0, 1, 2, 3, 4, 5. And it goes on forever and ever. However, notice I didn't list any negative numbers. So whole numbers do not include negative numbers. Okay, so whole numbers, no negatives. Then the next circle, that green circle, is reserved to describe integers. So integers are like whole numbers, where there's no decimals or anything, but it includes negatives. So like -1, -2, -3, -4. But integers also includes 1, 2, 3, 4, 5, 6. Okay, so integers is all of the negative versions of the numbers and all of the positive, okay? So see how that green circle goes around that tan circle? That's because integers include all of the whole numbers, okay? So the only change between integers and whole numbers is that integers includes the negative numbers. Next, outside of integers is something called a rational number. And remember on the last page, we talked about how a rational number is any number that can be written as a fraction. So any number that can be written as a fraction, so that means like if I had like 3/4, that is a rational number. Or remember, decimals can also be written as fractions. So if I had like 0.25, that's rational. If I had 0.333 and the 3's just kept repeating, maybe you remember when a number repeats as a decimal, you can put a bar over it, and that tells the person reading it that that number goes on forever and ever. So repeating decimals, regular decimals, really, really crazy big numbers. And rational numbers also include all of the integers, so the positive and negative versions. That includes the negative versions of fractions and those decimals that can be written as fractions. And rational numbers also include whole numbers. Okay? Then you see all that white space over to the side? That's reserved for numbers that are called irrational. So irrational numbers are numbers that go on forever and ever without stopping. So like pi. The number pi goes on forever and ever, right? Sometimes we shorten it up and say 3.14, but that's just if we round it. So pi itself, though, goes on forever and ever. And if I did like the square root of 2, that becomes a decimal that goes on forever and ever. It never stops. So that would be an irrational number. Or square root of 13, square root of 11. Some of you have maybe even heard of the number e. That is an irrational number. It's another decimal that goes on forever and ever. But the interesting thing is a number cannot be both rational and irrational. It can only be rational, or it can only be irrational. So that means if I'm looking at a whole number, that whole number is also rational. because it's part of the rational side of the picture. It's not irrational. Okay? So anything in that yellow circle is a rational number. Anything in the white is an irrational number. Okay, so now let's practice classifying these numbers. So if we look at that very first number, we have negative 2 and 5/6. Okay, so remember, we have a negative. So that means it couldn't be a whole number, right? There's a fraction, so it can't be an integer either. So that means it is just a rational number. And it's rational because it can be written as a fraction. All right, 45. Well, 45, that's a whole number, right? But it's also an integer, because remember, integers aren't just the negative versions. It's also the positive versions. And it is rational. So for 45, you would have to write all three of those. You can't just write down one of them and get it right. You have to list all three of those words. And then the next one, I have 1.3133133. So notice that there's nothing that's repeating in a regular fashion, right? Like here the 3 repeats once, then it repeats twice, then it just goes on and on. So since that number, it doesn't repeat, I can't change that into a fraction because I don't know what these numbers are. So since it can't be written as a fraction, this is irrational. And if it's an irrational number, it can't be anything else. It can only be irrational. So then I'm done. All right, so that's example 1. Now example 2, we're going to practice converting from fractions or whole numbers to decimals. So remember, if I want to write this as a decimal, what you can do is, I have a whole number, right? So I'm going to write 7 point, and then this is saying 5 divided by 6. So if I type in 5 divided by 6 on my calculator, I should get 0.833333. So that 3 ends up repeating. So my answer would be 7.83 repeating. And that's all I would have to put for that one. When you start with a whole number, that's pretty nice. You just do 10.0 because there's no fraction, right? So it would be 0.0 to represent the fact that there's no fraction. So all done with that one. And then the last one, I have 14, and then I have a fraction that's going to give me my decimal. So I do 2 divided by 3, which is 0.6666, so that 6 just keeps repeating. So I would write 14.6 as my answer. If you want to, actually no, we'll leave it like that. Then example 3, let's practice going the other way. Let's take the decimal and convert it to a fraction. So here you can see I have 0.34. So I take those numbers, so 3, 4, and I put it over 1, and then however many numbers, so 3, 4, that's 2 numbers. That means I have 1, 2 zeros. So 34 over 100 would be my fraction, except I can simplify that fraction a little bit, so I'm going to. I see I have 34 over 100. I know both of those are even, so I'm just going to start by dividing by 2 on the top and the bottom. So then 34 divided by 2 is 17. 100 divided by 2 is 50. So I have 17 over 50 as my fraction. And then I'm done. That's all I have to do for that problem. Then over here, you can see I have a whole number, so that's going to be out in front of a fraction. And then I take my number, I put 1, and then since there was only one number, I have 1, 0. And 7 over 10 can't reduce, so my answer is 1 and 7/10. And then the next one, I have 375 over, and since that was 3 different numbers, I'm going to put 3 zeros. And then if I want to simplify that, I know that I can divide by 5 on top and bottom because both numbers end in, 5 and a 0. So if I divide by 5, I have 75 over 200. And again, they end in 5 and 0, so I can divide by 5 again. So then I have 15 over 40. And again, they still end in a 5 and a 0, so I can divide by 5 on top and bottom. 15 divided by 5 is 3. 40 divided by 5 is 8. So my final answer would be 3 over 8, or 3/8. Okay, so first you set up the fraction with the numbers you were given over, and then however many zeros you need to add. And then you simplify. Okay, but what if you have a decimal that's repeating? How on earth do you solve that? So 0.7 repeating, that's the same as me saying 0.77. And I could just stand up here writing sevens for a really long time, but you would get bored and I would get bored, right? So instead of putting that many sevens over that many zeros with a 1 in front of it, there is a trick to it. So what you're going to do is you are going to you're going to say x equals, okay? So you start by saying x equals, and whatever your repeating fraction is. Okay, so in this case, x equals 0.77, and I wrote just a lot of sevens, right? Then what you're going to do is I want you to write 10x above it, and then if you multiplied that blue number, so that's 0.777, if you multiply by 10, remember all that does is move the decimal place. So then what you can do is you have 7.7777. So all we did was we changed it so there was a number there. Now, your next step is going to be to subtract, okay? So if I have 10 x's and I subtract this 1x, 10 x's take away 1, it's going to leave me with 9. Then 7.777, all of that minus 0.77. These would cancel, right? Those would all become zeros. It's a lot of zeros, right? But 7 minus 0 would be 7. So basically, 9x equals 7. So I would have 9x equals, and then to get that x by itself, all I have to do is divide by 9 on both sides. So then my fraction is 7 over 9. That is my final answer. So x equals 7 over 9. So one trick for you to remember, see how there was one number that's repeating over and over? What you can do, the shortcut is you take that one number that repeats over and over and you put it over that many 9s. So in this case, there was one number repeating, so it got put over 1/9. And my answer would be 7/9. So when it's repeating, instead of putting it over a 0, you put it over a 9. All right, example 5, 0.42 repeating. So now notice there's 2 numbers repeating. So what I'm going to do is I have 42, and I had 2 different numbers repeating. So my fraction would be 42 over 99. And then I'm going to simplify that fraction. So 42 over 99. Both of those numbers are divisible by 3. So this would become 14 over 33. Okay. And that is everything that I have for you in this lesson. I know that was a lot of vocab and a lot of me talking, but hopefully if you use your little picture, the graph, to help you name all of the different numbers, that should help. And then practicing converting between fractions and decimals. And then we just talked about some repeating fractions. So hopefully that isn't so bad. But if you have questions, don't hesitate to reach out for some help. I'm more than happy to help you. Have a great day.